So in the kind of prequel lesson to 9.3, I'm going to show you how we can simplify radical expressions, because we're going to be solving quadratics in the next lesson using square roots. And so we want to be fluent with working with different radical expressions and doing a few operations with them as well. So if we look at this irrational number, the square root of 20, I want us to think, how do these two compare? So we're going to look now at, is there a way that we can see this to where we understand that these are actually the same expression? They have the same value. So here's how this works. This can be rewritten as the square root of 5 times the square root, let's do it all with one. We'll just say it's the square root of 5 times 4, right? Which it is. 5 times 4 is 20, and so we can put both of those under the radical sign, okay? So that's the same as saying the square root of 5 times the square root of 4, because they're both underneath that radical, so we can separate them into two different terms. So let's look here. Are there any perfect squares? Yes, and that's really why I chose those two numbers, because if I use 10 and 2, 10 and 2 are not, neither of those are perfect squares, but 4 is. So my goal was to pick a number that was a perfect square, a factor of this original number, because now what we can do is we can factor that out. This is the same as saying the square root of 5. Well, what's the square root times the square root of 4, which is 2. And because this can be factored, it now goes here. So this is saying 2 times the square root of 5, which is exactly what we got up here. Let's look at another one. We'll look at square root of 36. Now, we know that this can most simply be written as just a 6, right? There's another way we can write it too. This, if we do 9 times 4, those are both perfect squares. Square root of 9 times the square root of 4, well, that gives me 3. Square root of 4 is 2. And that's another way of seeing how we can also get the 6. 3 times 2 is 6. So that's what that simplifies to. Okay, one more. Scoot over. Square root of 72. 72 is not a perfect square. We can get it by multiplying 9 times 8. 9 is a perfect square. That equals 3. So what we get is 3 times the square root of 8. And actually, we could have factored this out some more. So let's think of another way to do this, because we can factor this more. So instead of using 9 and 8, we could use 36 and 2. 36 is a bigger perfect square. So if I did 36 and 2, I would get 6 times the square root of 2. So this would actually be a more simplified version, because if you look here, our number is bigger on the outside. So we were able to factor more of it out. How are you going to know that? Well, always try to think of the list. If you need to, list the factors of the number and choose the largest square, a perfect square number that you can. You want the largest perfect square to factor out. Okay. So now, let's look at what happens when we have some variables. So let's say we have a mix of both. And we want to factor this. Simplify it by factoring, okay? So we can rewrite 63 as 9 times 7. 9's a perfect square. And then x to the 9th, think about what numbers are perfect squares in here, and we can factor that out. So 9 is a perfect square, so really we can say that this is, well, we can just leave that there actually for now. We're going to pull these out. So take the square root of x to the 9th, you get x cubed, and then 9 has a perfect square of 9 is 3, so you're left with 3x cubed times what's left, which is just your 7. So let's see what happens when we now have some numbers and variables together, and we're going to see how we can rewrite these radical expressions. We're going to factor out what we can. We're going to factor as many of the perfect squares out as we can. So we can rewrite 63 as 9 times 7 because 9 is a perfect square, so I want to be able to factor that out. And then x to the 9th, we could do, remember when you're multiplying expressions with the same base, you add the exponents. So we need to equal 9. So we can pull out 2 of the x to the 4th, which is x to the 4th squared, right? That gives us x to the 8th. Then you have 1x left. Okay, so this means this number has been squared. This undoes that square. So we can pull out x to the 4th, okay? And then the square root of 9 is 3. What's left is we have 7x underneath the radicand. So we factored it out using the biggest perfect squares that we could think of for the coefficient and the exponent for the variable. And then since this was repeated, this means this is x to the 4th squared. So we factored out x to the 4th, got rid of those, factored this out to 3, took the square root, and this is what's left. So sometimes that could be a thing. The last thing I'm going to show you is what to do when you need to multiply them. Let me put that. So these numbers are outside. These are being multiplied. And these two numbers are out front. So we can just multiply these. We get 6, okay? Now we can take what's underneath this radical and we can multiply that. So we multiply these and we get 80. And then x to the 4th. Okay? Nope, this is 75. Okay, so now I'm thinking, how can I rewrite what's under this radical and make it to where I'm pulling out perfect squares? I want to rewrite it with factors of perfect squares. So 25 is a perfect square. I would need 3 of those. So then I would do 25 times 3. That would give me my 75. And then what perfect squares are in here? Well, that would be x squared times x squared. That would give me x to the 4th power. So now I'm going to factor more out. I still have this 6. Okay? So now I'm going to have a 5. Square root of 25 is 5. Square root of x squared times x squared is x squared. So we get 5x squared. And then that's being multiplied times 6. Anything that I have pulled out is being multiplied on this side. Okay? What's left is the square root of 3. So I'm taking 6 times 5x squared, put that together, that is 30x squared times the square root of 3. So that is how you work with your radical expressions when they're being multiplied. You carry out the multiplication, rewrite to see what perfect squares you now have that you can factor out, and then simplify anything else that's still left that can be multiplied outside of the radicand symbol. Okay, I'm going to do one more that involves a fraction just so you can see it's not scary. We're going to do the same exact process that we did before. So the first thing we're going to do is multiply these numbers. Half of 4 is 2. And then we multiply these. 21 times 7, that gives me, so we have 147, then x to the 5th. Because we're multiplying these, we add the exponents. So now we'll see what else we can do here. So I'm looking for perfect squares. So this time maybe I'm using a calculator, some sort of method, strategy, tool to help me, because 147 is kind of an odd number, literally odd, but an odd number to work with. So can't do 25, 36, maybe 27. So I'm going to work on that, you work on it, and then we'll come back and see what happens. So we get 49 times 3. We can do x squared, and then another x. This can be factored out. This can be factored out. We're left with square root of 3x, and we still need to multiply the 2. So we get 14x squared times the square root of 3x.